Greetings, this is Artie from Artifact Electronics. You're looking at my TRS-80 Model 1, which has been featured in some previous episodes, and if you haven't seen those, go ahead and watch those. Even though this is kind of an independent episode, where really prior knowledge is not required, even though I may refer to those episodes, but I'll try to make this as independent as possible. So he got some new appendages. First one was he got an actual real disk drive, a 35-track original drive with a Shugart SA 400 drive, 35 tracks, single-sided, single density, holds about 85K. But we won't waste any time on that. The real prize was this. So what I got for him was the Radio Shack TRS-80 voice synthesizer. It's a phoneme-based speech synthesizer that Radio Shack came out with in the late 70s. I might as well say it right beforehand, this thing didn't sell too well. I think it was for two reasons. One was it retailed for $400, and that's about 2/3 of the price of a complete starter system, which included the computer, display, and a cassette player. And second of all, the speech quality, even for that time, wasn't that good. And I think it had more of a novelty value than anything else. But why don't I let you be the judge of this and have it speak to you. A few details about it. It basically is plugged into the expansion port on the computer, and the way it works is 32 bytes of the screen memory are mapped such that the speech synthesizer picks up anything you write into that area, and in the order that the characters appear there, it interprets the data as phonemes and vocalizes them. And that pretty much describes how this works. So let's have a listen. I got some programs. There are not that many programs for it because there weren't that many of them sold, so developers were generally not interested in supporting it. But I'll show you some of them, and for you to see what this thing sounded like. So the first demo I have was a in-store demo that they ran. Well, I think it was intended to run continuously, but it basically drove everybody crazy, so they probably ran it for like a minute in the morning and then shut down the volume. So let's give it some volume and load the demo. If I can remember the file name, vcsyn rs1 bass.
Hello, this is a TRS-80 voice synthesizer demonstration program. I can be programmed to speak any words by using phonemes.
Try not looking at the screen
For example,
and see if you understand what he's
the
saying.
phonemes in the word hello are hello. The phonemes in the word compute are compute. The phonemes in the word C are C.
Not very good with fricatives.
The phonemes in the word zero are C. phonemes are listed in your operator's manual.
And it basically looped back to the beginning and did that all the time. So now you know what it sounded like. But I think what's more interesting to have a look inside and see how it generated all this wonderful speech. One point of note is that this synthesizer is probably the only accessory to the TRS-80 that was sold that actually had wood in it. The case is made out of wood and painted silver. Everything else was mostly plastic, or, as in the case of a disk drive, some metal. But that was the only thing containing wood. So I started to look for the operator's manual as referred to in the demo, because I wanted a list of the phonemes. And as we shall see now, I don't know what the actual voice synthesizer they use is. So Google wasn't my friend looking for the operator's manual, but it redeemed itself because this is what popped up, the service manual, which still doesn't contain the actual phoneme list, but at least tells us what's inside, at least partially. And having a quick look at this, we have, of course, a power supply, just a linear supply, generating 5 volts for the logic and 8 volts for the audio amplifier. And then here comes the interesting part. Has this big block that says proprietary section, and that's where the speech comes out and is pumped into the amplifier. That's not good, and I'll tell you why. Because as we advance in the schematics, half of the digital logic here, it's basically just nickel and dime glue logic that monitors for certain address accesses, and if it's within the 32-byte window, as I mentioned earlier, it actually passes them through, like here, and pretty much everything, even though it's not clearly shown over here, the data ends up, guess what, in the proprietary section. So what is this proprietary section? Is it a chip? Is it a something potted? Is it a potted module? I don't know. And in order to see that, we're going to have to take the synthesizer apart. But again, you know, here's a continuation of some of the glue logic, and not much happening here. And the LED lights, every time that it detects a new piece of data written to the 32-bit window on the screen, that was the red LED you saw in the front of the unit. Alright then, open sesame. So we got to pull the volume knob off. And then even the back plate is made of wood. It was in the 70s. It's still cheaper to make this kind of stuff out of wood. Or if you sold a box like this for $400, that probably didn't matter much. But so we take the back plate off, and here's our circuit board. Let's get a better look. So here's what it looks like, and of course we can all see immediately. Can you say potted module? So here's the mystery module, but then I looked at it again, and there are a lot of chips on here. I mean, compared to the schematics, in the schematic we could probably see, what, 8, 9 chips? But there's a lot more than that on here. So I did a little closer analysis, and as it turns out, and the way the board is kind of labeled, because see, it says potted over here. And then it says somewhere over here, it says not potted. Of course I can't, oh, unpotted, it's behind the one of the regulators. Where'd it go? Oh, here, of course you can't see that. But it actually says unpotted over here. And after closer analysis, so basically the first page I showed you with the power supply, I mean everything I showed you, the 3 pages of schematics, starting of course with this power supply, are basically this section of the board, starting from here and going all the way over here. So they give you the schematics for this part, and this is the proprietary section, this entire thing. And if you look at the chips, they've all been painted over, and I tried to unpaint them, but I used starting out with alcohol and going up to acetone. I even used some paint thinner. They used some really good stuff on here. It won't come off. I mean, that top layer. Some of the chips, if you hold it just in the right light, you can kind of, like on this one, you can kind of see the writing. But there were only 2 or 3 chips that I could identify that way, and they were just plain old TTL chips. So all the good stuff is hidden from us. And an interesting note in the service manual is it basically says if this thing doesn't work, it's most likely in the interface section over here. So fix it and you'll be okay. But if it's not in here, you're out of luck. Send back the whole unit and we got to replace it. So everything from this line to the left is unrepairable. Now what this contains is probably the actual processor containing the speech synthesizer, and I really don't know what it is. If you have any idea, let me know. I know it's not the Votrax SC01, which was used like in Qbert arcades. The General Instruments, what was it, the Allophone chip that, which was my original guess because Radio Shack actually sold those chips a few years later for experimenters. But it doesn't really, it sounds different, but that may be that this is an early prototype in here of that speech stuff, and that's why they potted it and hid it from everybody, because they didn't want you to know. It's not a TI part, because at that time, even the Speak and Spell TI was much clearer, and it came out in the early to mid-70s, and it had very good speech quality. But I guess they used linear predictive coding, and it was also phoneme based, but the bottom line is I don't know what's in here. Not that it really matters, but it would still be interesting to know. When I originally got this, it actually worked for about 10 minutes. I plugged it in, I ran a demo program, I said, well, great, you know. Of course it was sold as unable to test and doesn't do anything, and well, you know, that's what you expect. I mean, they're not that easy to find. They do pop up, but they're still pretty expensive. But I really had to have one of them, so I bought it. But anyway, after the honeymoon was over, it developed a very loud audio buzz. And so I played around with it, and it was still talking, but the buzz pretty much drowned out the audio. And the audio sounded pretty horrible. But one thing I noticed was that the volume did not affect the volume of the buzz. So that in itself was a dead giveaway. Look at all them pretty electrolytics. Well, I tested them all, and they were all good. So that didn't really leave a whole lot else. This is the resistor that feeds that basically dampens the speech signal. The speech signal is here, and here's the output to the audio amp. So when just putting an amp on either one of these, the buzz was still there. So what I did was I lifted this resistor and I just monitored this side of it, which wasn't connected to the audio amp side. And the buzz was gone. I could hear the speech, but it was really broken up. It didn't sound anything like it sounded when it was in the original, during the honeymoon, the way it sounded during the honeymoon. So with all of those clues in mind, it was pretty much, I narrowed it down to the power supply. But I checked the capacitors, they were okay. The voltage coming out of the two regulators was okay. But then I looked at it on a scope, and there was basically half a sine wave riding on top of the input voltage to the regulators. That was a big problem. And since the caps were okay, I'll let you gaze at this again. There really isn't a whole hell of a lot more left in here that could go wrong. And regulators are okay, caps are okay, power coming in is okay. Well, yes, you guessed right. It has the rectifier bridge, and I couldn't hope for that to be bad. It had to be something real complicated, right? But I measured it, and it turned out one of the diodes in here had opened up, and that would cause those symptoms. You can't control the buzz with the volume control, and it also affects the speech, since both the 5-volt and the 8-volt supply probably, not probably, but had a pretty good sine wave, or partial sine wave, riding on top of the DC. So all of that made sense, and here's the bridge. It doesn't have individual diodes as shown in here, but rather using an integrated bridge. And so what I had to do is hunt for a bridge, and yes, I used a used part. I pulled it off I think it was a switching power supply for a plasma TV or something like that. Anyway, I put this thing in, and that was it. Fixed the problem. There's not a whole lot else to say about this. Why am I not swapping the caps? Because my philosophy, if it ain't broke, don't fix it. Yeah, the caps will have to get fixed eventually. They've probably aged. But so far everything sounds fine, and especially after changing the bridge, everything looks okay. And another thing is this probably wasn't used that much, so the caps, they've hardly degraded from use. But time does horrible things to electrolytics too. So to make it really bulletproof, all of these caps need to be replaced. But that's for another time. And there's really not much more to discuss about this, because they did a great job of camouflaging everything. And I think if they had their say, they would have potted everything from here on to the left, but Bean Counter probably told them that would cost too much in the epoxy, so they just built a little plastic box that hides the heart of it and filled that with epoxy. This unit came from Florida, and I've bought other things from Florida. There's lots of neat stuff coming from there, but it's very, very, very humid in Florida. And one of the problems is you buy stuff, and pretty much any unprotected metal will most likely corrode or rust. Now on this one, this is wood, as I mentioned. You saw the PC board, that looked nice. The plates, probably aluminum, it's okay. So I went ahead and I hunted. I had to find rust or corrosion somewhere on this. It was almost like, so did this originally live in Florida, or did it come from somewhere else? And after some hunting, I finally found it. The inside of the volume knob. And this is what came off it. So I found some rust in it, and my theory of things coming from Florida having some corrosion or rust was yet again proven right. So here's another demo written by a third party. And do the same test. Don't look at the screen and see if you can actually tell what he's trying to tell you.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9, cancel, add, subtract, multiply, divided, equals, enter, buffer, all, run, up, end, ready, save, hello, thank you, how are you, I'm fine, yes, no, 0, 1, 2.
So how did we do? Did you understand everything he said? Well, I guess it's passable, but I don't know. Leave me a comment and let me know what you think of the voice quality. And finally, what I think was meant as the flagship product, or the launch product, software product that would make this a very desirable unit, which was called Eliza and was supposed to be real artificial intelligence. And they added a version that was usually a text program, but they added this version that actually spoke the answers.
How do you do? Please state your problem.
So he wants my problem.
Is that why you came to me?
So it doesn't print the text on the screen, so you got to listen real close. So what he said was, "Is that why you came to me?" For those of you that didn't hear it.
What are the reasons might there be? What does that suggest to you?
I didn't understand the next to last word. What does that attest to you?
Can you elaborate? That is quite interesting. How long have you been that way? Please go on. Why do you that?
So as you can see, you can have hours and hours, or I should rather say minutes and minutes of fun with this. This was the flagship artificial intelligence application to show off the voice synthesizer, and I played with this before I took this video, because I really wanted to have a somewhat interesting sequence of discussion going on with this, almost somewhat script what I would tell it and see if it gave me any interesting answers. But the more I tried, it basically gives you the same answers all over the place. But I guess it was considered a good demo for the voice synthesizer. But there you have it. Well, I hope you enjoyed this foray into early speech synthesis. Let your thumb do the talking, and make sure to subscribe. Now, I've been thinking about I'm having a hard time finding things to put on this channel, I mean, in the beginning it was kind of relatively easy to find things that were cheap, but like everything else, things to repair or to show that are interesting are few and far in between, and when you find them, they get kind of expensive, like this voice synthesizer. So if any of you would have a piece of equipment that they would like to donate, let me know in the comment section, and I'll set up a compath so we can discuss it. Of course, you can also donate untold riches, like the deed to a piece of land in Monaco, or anything like that. But I think it would be much more interesting and beneficial to all of us if it was just an interesting piece of electronic equipment that needed some repair or at least a teardown. So let me know, and have a great tomorrow.